Have you ever really thought about how our planet, our home, came to be? I mean, it's easy to take for granted, but our world was once a boiling ball of lava. Seriously, a fiery, hellish place with zero signs of life. It's an absolutely incredible transformation, and today we're going on a journey, a 4.6 billion year journey, to see exactly how it all happened.
So yeah, that's the big question, right? How does a sphere of molten rock turn into this lush blue and green world we live on? Where did our oceans come from? Our moon? The very air we breathe? Well, believe it or not, it all starts with the birth of our sun.
Okay, let's rewind the clock. Way back. We're talking 4.6 billion years ago. Forget the solar system, it doesn't exist yet. All you've got is this massive, quiet, and really cold cloud of dust and gas just kind of floating in the dark. This cloud, which we call the solar nebula, was mostly just hydrogen and helium, and it just drifted out there for millions of years.
And then, everything changed. A nearby star died in a spectacular explosion, a supernova. The shock waves from that blast slammed into our quiet little nebula, causing it to start collapsing in on itself. As it collapsed, it started to spin faster and faster, flattening out into this giant rotating disk. All that gas and dust began spiraling toward the center, where the pressure got so intense, so hot, that it triggered nuclear fusion. And boom, just like that, our sun was born.
Now here's what's absolutely mind-blowing. The sun is just unbelievably dominant. It basically ate everything. An incredible 99.8% of all the material from that original cloud went into making our star. That left a teeny tiny fraction, just 0.2% of cosmic leftovers for everything else. I mean, every single planet, moon, asteroid, and comet, all of it came from that 0.2%.
So, what happened to that tiny bit of leftover stuff? Well, that 0.2% is where our story really gets going. It was the raw material, the cosmic scrapyard, where the universe started building entire worlds from, well, basically nothing but dust. The whole thing works because of one key process. It's called accretion. And it's actually a pretty simple idea, but it's incredibly powerful. You've got tiny particles of matter, and gravity pulls them together. They start sticking to each other, forming bigger and bigger things over time. This is literally the instruction manual for how to build a planet.
You can kind of picture it like a cosmic assembly line. First, tiny little dust particles just start clumping up. Over millions of years, these clumps grow into these kilometer-sized rocks we call planetesimals. Then, things get really interesting. The gravity of these planetesimals gets strong enough to start pulling in others, and they start smashing together, forming much bigger protoplanets. We're talking objects the size of our moon or even larger.
Now, this early phase of Earth's life was not peaceful at all. It was an age of unimaginable violence, a period of constant fiery collisions that we call the Hadean Eon. And yeah, it's named after Hades, the Greek god of the underworld, for a very good reason. Earth was literally a vision of hell.
For more than 500 million years, our young planet was just getting hammered, nonstop. Protoplanets, huge asteroids, they were constantly crashing into it. All these impacts generated so much heat that the entire surface was just one big ocean of lava. But here's the crazy part. This violent beginning was absolutely essential. Those comets and asteroids that were smashing into Earth, they were packed with ice from the original nebula, and they delivered the very water that would one day fill our oceans.
But in all this chaos, among all those collisions, there was one impact that stood above the rest. One single catastrophic event that would not only reshape our planet, but would also give us our constant companion in the night sky.
It's called the Giant Impact Hypothesis, and the theory goes like this. A protoplanet, roughly the size of Mars, scientists have named it Theia, slammed right into the molten early Earth. The impact was so huge that the iron cores of these two worlds actually merged into one. A massive cloud of vaporized rock and debris was blasted out into space, where it got caught in Earth's orbit. And eventually, all that stuff clumped together to form our moon.
Okay, but how do we know this really happened? It sounds like science fiction. Well, the proof is in the cores. You see, Earth's dense iron core makes up about 30% of its entire mass. But the moon's core, it's just a tiny 1.8%. That huge difference tells us that Theia's heavy core must have sunk into Earth, while our moon formed from the lighter outer layers that got thrown into orbit.
And the rock samples from the Apollo missions pretty much sealed the deal. They have an almost identical chemical signature to rocks here on Earth.
And here's where this ancient history directly affects you today. The sheer force of that impact literally knocked our planet sideways, giving Earth its 23.5-degree tilt on its axis. And without that tilt, we wouldn't have seasons. That single, violent event, billions of years ago, is the reason you get to experience summer and winter.
So, after all that fire and chaos, the stage was finally being set. The constant bombardment started to slow down, and Earth began to settle, to organize itself. It started its long transformation from a uniform ball of lava into a structured planet that could actually support life.
This sorting process is called differentiation, and it's pretty simple, really. It's just gravity doing its thing. All the heaviest stuff, like iron and nickel, sank down to form the planet's dense core. At the same time, all the lighter materials, like silicon and oxygen, floated up toward the surface, where they eventually cooled and formed the mantle and the rocky crust that we're all standing on.
Now, this separation of layers did something amazing. It gave our planet a kind of superpower, an invisible shield that would turn out to be absolutely crucial for any life that hoped to survive.
You see, that churning liquid iron in Earth's outer core acts like a giant engine, generating these powerful electrical currents. And those currents create a magnetic field that wraps around our entire planet. This field is our shield. It protects us from the sun's harsh solar wind, a constant blast of particles that would otherwise strip our atmosphere away and leave Earth as barren and dead as Mars.
All right, so the planet's got its structure, it's got its shield. There's just one last major piece of the puzzle. As the surface finally started to cool, volcanoes were erupting everywhere, pumping enormous amounts of gases, including a lot of water vapor, into the sky. That vapor collected in the cooling atmosphere, condensed, and then it started to rain. And it rained and rained for millions of years, a torrential downpour that slowly filled the basins and created the world's first oceans.
When you step back and look at the whole story, it's like a recipe where every single ingredient had to be perfect. Earth ended up just the right distance from the sun for water to be liquid. It's just the right size so its gravity can hold onto an atmosphere. It developed that absolutely vital magnetic shield. And it has just the right amount of greenhouse effect to keep things warm but not too warm. It was like a series of incredibly fortunate accidents, one after another.
So, from a quiet cloud of dust, to a supernova's shockwave, to a fiery ball of lava, and a planet-shattering collision, our home was forged. It's a story of chaotic, violent, and frankly, improbable events that all had to happen in just the right way, at just the right time. Which really just leaves us with one big lingering question. How rare is a planet like ours anyway?